Привет. Да, меня зовут Себастьян, и я работаю в качестве евангелиста программного обеспечения для IBM. И я учу русский, но я плохо говорю, so I think it's easier if I talk in English. I hope that's okay. So yes, welcome to the session on delivering progressive delivery with Jenkins X. So that's some news about me and my name. Actually, I'm super happy. So this time I finally pursued the organizers to print my name in, I like the Cyrillic writing, right? To print that on the badge. So I think I'm the only foreign speaker who has that on the badge, also in both ways written. But anyway, that's the small things that make you happy, right? So about progressive delivery and especially how to do that with Jenkins X. So in general, what I want to show you are a few things, a few experiences, how to deliver software in a modern approach, and especially how to make it accessible more for projects, for the enterprises, using cloud-native technology, right? So who of you does continuous delivery? Hands up. I hope all of you. Yeah, right? And especially continuous delivery in a way, well, how to deliver software, right? So that should be the culture in order to move fast in a fast-moving world. The question is, okay, how do we deploy to production? Of course, the answer should be, well, in an automated way, right? In a well-defined approach, in a somewhat pipeline or however you call that, using automation, using proper testing and verification, and a few things that we will come to. And, well, of course, in that way where we can just ship software with reliability, with quality being built in, with speed in terms of moving fast, and in a way that we assure, that everything works well later on in production, right? So that is an interesting thing already, and especially if we look into the world how we now typically deploy our software, right? There's this buzzword of cloud-native technologies that might include containers, that might include Kubernetes. Then this might become not let's say a challenge how to build all of these together, right? Because it's one thing to deploy, to deploy a Docker container, to write some YAML for Kubernetes, but how to put all of that together in an approach that is, doable in less than a few months, right? So who of you uses Kubernetes? Hands up. Okay, well, that's quite a few of you. And well, what I will show you from Jenkins X is actually, all of it is based on Kubernetes, so I will come to that in a second. If you're not interested in Kubernetes, then you can basically leave the room. I mean, that's pretty much married together with a Kubernetes approach, but in general, that is one way, the de facto standard how to run software, and Jenkins X shows also one opinionated way how to go there. So JenkinsX.io, that is the website. Jenkins X has, well, most of the thing that it has in common with the old Jenkins that you probably know, the traditional Jenkins, is the name, not much else. So what Jenkins X does, it's basically continuous delivery for cloud, pun intended, cloud with K, with Kubernetes, so basically a cloud-native based workloads. And it builds on Kubernetes. And what it does, it basically provides that glue for all of these components that we need to put together, right? You need to run something somewhere that basically applies all of these Kubernetes resources that you have. And the nice story about it, it comes with a lot of things, opinionated approaches out of the box. So that means you don't have to start from scratch, you don't have to start from zero. It comes with an opinionated workflow that is based on GitOps and basically Helm charts. You can see what that is in a second. So Helm, another website, helm.sh, is pretty much a package manager for Kubernetes. What it is a sophisticated templating approach, how to template these Kubernetes YAML resources. We will see some code in a second. And that is basically a way to package some deliverables with a nice number and version attached to it, and then to deliver that into our cluster. It's based on that, and it's based on GitOps, which is a nice idea, basically putting everything that you have under version control. If you heard about 12-factor applications, that is pretty much a best practice. If, well, you have some artifacts defined, you want to define everything as code. Right? So our whole environment that we would like to set up is basically defined in plain text in a Git repository. using Helm charts, using YAMLs, using all kinds of things. But if you want to change your environment, you basically make a code change and push that into a version, into a versioned repository, and then it will be applied. How that is implemented, and that is now the combination with Kubernetes, is it's implemented via Tecton pipelines, originally Knative, based on Knative, and well, webhooks. So what it does, now in the latest version, what is also called Serverless Jenkins, you don't have a single instance anymore of a single, CI/CD server, what you had with Jenkins, but it's more like an event-based architecture where you put all of that together. So some ASCII art diagram here. How that opinionated workflow looks like is, well, you have, let's start here, you have a Kubernetes namespaces, for example, 2 namespaces for your staging environment and for your production environment, might also be 2 different Kubernetes clusters. And then what you do, you run some pipelines in Jenkins X, and these pipelines are, again, you don't have a single server. They're more like put together by these events that happen, and then with Tecton pipeline runs. So, you run some pipeline, that means you might build on a pull request when you make some changes, and then you produce some artifacts, for example, in a Docker repository and in a Helm chart repository. And then what you do, if you want to deploy, you deploy basically by making changes in that GitOps environment by releasing something using Helm. So you just release and deploy that Helm chart. If you, for example, merge a pull request, so that is then again this opinionated workflow that you deploy something by introducing new pull requests to the GitOps repository, apply that to staging, and then what is called promote. You promote it to the next environment by basically deploying that to production. All right, showing enough code here. I want to show you some code. I use usually Java. So I have some live demo example using a Java Enterprise approach that I call Zero Downtime and Yaluplu Coffee. So I show you some coffee shop Hello World example where I basically deploy something here. And that is, a very basic Hello World example that deploys something using, this output. And I can say, okay, that is actually already deployed. So I have a staging environment that says coffee, and I have a production environment that also says coffee. So what I can do, I can have a look at my applications that are now basically deployed. And what I want to show you is this JX command line tool. Jenkins X, what most of it is, it's basically that command line tool, JX. And what it does, it provides all of the integration into your Kubernetes environment. So everything you see here is basically managed by, setting it up using the command line tool and providing all of these, events and hooks. And then what you do as a developer or as a DevOps engineer, you use that command line tool to access Jenkins X to, for example, see the status, right? So see, okay, what applications are deployed now. Now, applications here, that corresponds to the Helm charts that are currently being deployed. So that version for staging and for production, that's that same version. And then, you could have a look at multiple other things. For example, JX get the pipelines and see what's going on there. So that is basically that DevOps, that GitOps environment for basically my cluster environments that I have here, staging and production, and my pipeline for my project and things like that. And then let's have a look at that. I actually can see the activity in my pipelines, and I was running that before. So that will show the pipeline execution of something that, runs, right? But in order to run something, I need to change something here, right? So let's change coffee to coffee exclamation mark, or better yet, coffee, right? You have no idea how hard that is to type if you only, learn to type in a English keyboard and never on a Cyrillic one. So let's do this and then say, okay, changed response. Now what it will do, I have a code change and I will now commit and push that code change. And then what happens, using webhooks, I will basically provide that integration with, my Kubernetes cluster. So I go to public GitHub, I push it, And that will then go to my Jenkins Kubernetes cluster, and well, we'll make sure that a new pipeline starts. And this will take a while. And then basically that pipeline, that master branch pipeline, so I push to the master branch, will run and then do all of that workflow that I just showed you in the diagram. And then what it will do, it will deploy to staging, and then I could have a look at it, and depending on that workflow that I built out of the box, it will need an explicit promote before it goes to production. So I could have a look at it on staging, and then I can promote if I want, right? So then I get my change. So that is basically what I want to show you right here. We could have a look at that in my environments here. So I have these environments for staging, for production. So that is an actual repository. I could change all kinds of things. And then what happens, and I can show you once that is running. So this is one example of how I can define all of the dependencies and versions that I use inside Helm. So for example, I tell it, oh, please use this version of, well, my application. That applications that you will find in that Helm chart. So now we see actually that it is running here. So that is currently the execution of these different steps. So the steps I have in my pipeline, that is also, an opinionated approach of what runs here, get build block. I can have a look at it using this command of whatever pipeline run I have, and I say please have a look at that master branch. And what it does, well, this now shows all kinds of things in my pipeline that I set up from, well, first of all, the Maven build, right? What do I need to do to deploy this? That is a Java project built via Maven, what you saw in the POM XML, right? So I have to do that Maven build here to build this into, I use a thin war file deployment approach. Then I need some Docker image, right? So that is my Docker file that, of course, also resides in the repository. So that what I will do a Docker build using scaffold, actually, because, well, it's not that easy to build, Docker images inside a Docker container. And of course, that Jenkins, it runs Tecton pipelines, right? So it runs as a Docker container. And then the question is how to build these images. So that uses the scaffold build, so that output looks a little bit differently to what we are used to if we would fire up a Docker build, right? And then what we do, we have, well, a way to promote these Helm charts. So basically what we do, we say, okay, build this Docker image, right? And then define my other deliverable, my Helm chart, by defining that version in this Helm chart. And how that looks like, who of you has seen Helm charts? Hands up. A few of you, okay. What it basically does, I say, this is my Helm chart for, my application. That version will be changed, and I have, some definitions here. For example, my deployment, where I say, okay, if you use Kubernetes, you've seen, a deployment before. I have one example here for this coffee shop. That might be, do I have one? Yes. No, a deployment looks something like this, right? That's a fully-fledged deployment. What I have here is basically a templated deployment. So I can say, okay, say so and so many replicas, but for example, replace these values. And where these values come from is there is a values YAML, of course, more YAMLs. Let's say, okay, the replica count should be this and that, right? And there's a service definition and so on and so forth. We will go to the canaries in a second. But that is basically the values that we replace in that Helm chart when we put it together and when we release it, basically when we deploy whatever we want to deploy here. So we say we define the basic parameters here, however, whatever Kubernetes resources, these YAMLs we want to have, and the actual values are then replaced by during the pipeline run. And now we see, okay, this already succeeded, and then in our repository here, we had a pull request that is per default already merged. And that pull request, well, what it does, now GitOps, that's the interesting thing, it will see, okay, it just changed a version in my Helm chart. So what it does, I built that Helm chart using that new version, I store that. Where is this? Actually, this is also part of my cluster. So if we had a look at the architecture of the components that come with it, so there is even Helm chart, chart museum, that's that repository, stored in my cluster. I could store it somewhere else, but whatever. And then I just say, please use this new version, which will be applied, right? So GitOps now it's everything based on that version on that repository. So I just have a new commit that changes the version, and that will be applied. So now at some point we would see a new version here, version 28. And if I had a look at my staging namespace, then, oh yes, it's already up and running. It actually redeployed my pod in that staging namespace. So now, if I would have a look at curl, that is my production. It says coffee. And now that is my staging environment, which now says coffee, right? So that is just applied to staging. That happens out of the box if I run this pipeline, so I could test that if I want. And that is already a nice idea, because now I can focus on coding, and this will be applied, in this case, using Jenkins X, using Helm charts and that GitOps-based approach. All right, but now that's still kind of boring. What we want to focus on a little bit more is progressive delivery, right? So that is just continuous delivery with automated deployment to some staging environment based on Kubernetes and Helm charts and a bunch of other things. But now the idea behind the progressive delivery approach, especially using Jenkins X, is, well, what is progressive delivery? It is a way to do that delivery, to deliver our software by limiting, boom, the blazed radius. So instead of deploying something that might, of course, fail, and then we do a big bang deployment, big bang like this, of saying, okay, even if we have things like blue-green deployment approach where we have some zero downtime, to make that switch without losing a request, even then, at some point we just switch to the new version and we switch 100% of the traffic, right? All of the users now go to the new version once that is deployed. And that is basically that big bang, right? Because if you then, for some reason, have an error that for some reason you didn't notice before, that you didn't catch in a staging environment or in some test environment, then of course all of the users are affected. And now the idea is to limit that blast radius by introducing what is called canaries, right? And also introducing them and rolling them out in an automated way, right? So what you do, you say things like, let's roll this out to 5% of the users first, right? So not everybody is affected. And then only if it works, then slowly increase that and see what happens, right? So that has been done many times before. I think you're very familiar with that approach. Or you say, let's roll this out to some friendly user testers first, right? To a specific subset of your users. But now what you do, using progressive delivery, you also include that with some automation to say, okay, let's have a look at the metrics, right? So you roll that out with 5% first, and then you see, okay, now in an automated approach, let's see how this 5% deployment is doing in production, where everything is blowing up immediately. Then you can roll it back, also in an automated approach, and then at least you only affected 5% of your users, and not everybody, right, in the worst case. Or again, you can increase that also in an automated way by checking these metrics and just, introducing automation for all of it by having proper, metrics and a proper, more scientific approach, if you want, by limiting, that radius of the users that are affected. So, how does that work? There are many ways to do that, and many companies have done that, themselves in the past. But now what I want to introduce you, and that's the reason why I show you, Jenkins X with some opinionated approach, is you can always do everything, yourself, right? Many companies have written their own orchestration in the past, things like Kubernetes, right? Once somebody said, Kubernetes is just a sophisticated set of shell scripts, right, if you want. And actually it's true. You can do that, right? You can run your Docker containers or whatever using some sophisticated way of automation, using scripting and whatever, and just applying that, basically applying the same approaches and concepts in a homegrown fashion. That is always possible. But of course, it's a lot of effort to get that right? Many teams need to be involved to do that in your own company, and that was actually the case, or is still the case. But now, same story with Kubernetes. What we want to have is an open source de facto standard way to do that for cloud native technology, right? So you probably have heard of this. Who of you uses Istio or has heard of it, has played around with it? Hands up, Istio. Now, what I will show you is basically based on Istio. That is a service mesh technology, and it uses sidecar containers to do, well, all kinds of things to enhance your applications with all kinds of features. And in this case, what we want to focus on is basically traffic management, to say if we have some sidecar proxy alongside of our application, then we have some more features, some more freedom where to route the actual traffic to. So then we could say, okay, now please route things accordingly. And basically what we will do here is to say, okay, in that canary release approach, we can actually route the traffic, like 5% of the traffic to, well, elsewhere, a different subset of our service, a different version. And this is what we will do using another tool that integrates with Istio. That's the reason why we'll use that. That is called Flagger. And what Flagger does, it again provides an opinionated, you cannot really say de facto way yet, but an opinionated way how to do these canaries using Istio. Right? So if you used Istio, we can have a look at that in a second. And basically you can define some virtual services and some routing where you define exactly this release approach of saying, please route 5% of the traffic, right? Or now 10% and the 90%, the rest routed here and this routed there. And then what Flagger does, it builds on top of it and provides, canary release resources, also YAML, also Kubernetes resources, also custom resource definitions, so same story, to do that in an also, sophisticated approach. So basically what we do now is, let's roll this out. If I have a look at my applications, then this is the new version that we now want to promote. So now what I'm going to do, I use that JX promote command to say, by the way, now I want to do some manual promotion. Of course, you could fully automate that if you want, to apply this version of my application, basically the Helm chart, to production. Okay, boom. So what this now does, it runs another pipeline, because what you saw before, there are also pipelines for the environment, and then it will create a pull request. Once that pipeline runs through, it will merge it, and so on and so forth, to basically apply that to production. Now, the difference is what we will apply is an approach that is only valid for that production environment, what we didn't saw before, and that is this canary object. So what it is a Kubernetes resource that now will take a reference to a deployment, for example, and we have that deployment already, right? Kubernetes deployment that runs our software. And what it will do, and that's a nice story, so we don't have to do things programmatically, but in the same approach, we do it in a declarative approach. We say, if there's a change in the deployment, if there's a new version, then please don't, do a big bang, but basically do a canary rollout with some, analysis. So we say, in every, minute or so, please increase it by so and so much, and also apply some metrics that, I can show you the fully-fledged example, that will tell us whether or not that worked. So this is just one example how that looks once we apply that Helm chart, right? Once we fill all of these parameters, so this is easier to look at. For example, to say, oh, now please take that deployment that is called, coffee shop or whatever in this way, and then do the rollout using some, canary analysis, and every minute, increase that by 10% or something like that, unless, you have so and so many errors, right? And what we will look at, and that's just one example. For example, we look at the success rate of your HTTP requests, right? So that is still successful. And it has to be more than, 99% or whatever threshold you define. And in the same way, we set up some request duration threshold, right? So if your application gets super slow and, under all of that average only responds in less than 500 milliseconds, and that is too slow, then we also declare it as failed and will roll back accordingly. So once that is being deployed, that takes a while as well. So good that we have a full hour. That is basically now rolling out, and what it does, it now defines two different parts. So that one was running the whole time, and this is now the difference that since we apply this canary object. What typically runs is zero downtime Kubernetes called primary. That is now a primary path, and then it will deploy a canary path and apply that accordingly. So we can have a look at some called events. So there's some login here involved, which will then log all of the events, everything that's happening in our canary approach. So we see that now that is being started up, and once that is up and running, it will actually increase, the output. And similarly, what we will do in order to generate some traffic, we go and have a look at our application. So that is now production, and all of it is still our version that runs just coffee. So I do let's do this. I continuously generate some traffic now. Oh, we already see there's something happening. And what we see, okay, now please do the deployment here, but now it says, okay, start that canary analysis and advance my service here to roll it out using that 5%. Sometimes it includes, that warning that it didn't receive the traffic yet. Well, that is because of the metrics that we see here. And let's refresh this. What my Flagger technology also comes out of the box with is this nice Grafana dashboard, which I can have a look at in this canary approach. So actually, that's a side-by-side comparison of my primary path and my canary path, right? So that comes also there out of the box in my Jenkins X cluster here if I install that add-on. And now I can have a look at, what happens here. Basically, we can have a look at the operations per second. So the left part here is the primary part that is always, that is deployed. And now the canary approach that we slightly and slowly increase. We can have a look at the success rate for each path, and of course the request volume, which then will be, oops, it was an internet hiccup, which then will be, increased. So then we see, okay, now it will advance, so and so much. What happens under the hood, if you had a look at Istio, these virtual services that basically route my traffic to one thing or another. So what it does, that is actually that route that this canary object creates, right? So what I do say, if you go into my cluster using that gateway, please route it accordingly to, either primary or canary, right? What it does, that's a default service that is also being set up with that Flagger. And now you can see, it basically routes, 70%, 30%, and that percentage will be increased. That is the nice story that this happens, using that technology. Otherwise, what happens? You would need to do it manually, right? I can show you another example that is not deployed, but just for you to understand it. What I would do, where's my routing? Typically, is to have something like, a virtual service that routes my coffee shop to, in this way, route 100% to here. Or do I have some? Oh, that's only a templating approach as well here. Or route it to, basically what you see here, to two destinations that correspond to two services that have been set up, canary and primary, that then route to these active pods. So that's basically the idea. And that is all of that is applied automatically. So then says, okay, go to 50%, and in my case, 50% is the upper limit. And once it, survives 50%, then it says, okay, now go and roll it out all together, and then, only get new responses once that is the case. And have a look at that virtual service, and after 50-50, it will be applied 100%, and then you're done, and then all of it is in production. Because we had a look at, well, two things. In our monitoring, we had a look at the success rate. In this case, it was just 100%, because it always just responded. That's good. And the request duration, like, the response time, which is also super fast. So all of that is green, and it will advance. It advanced all of the canary stages, and then it will be fully rolled out and done, right? So that is a happy path, good example of how we can roll this out in that canary approach using progressive delivery and using Jenkins X. In this case, with Istio and with Flagger. So now the point is, this is just, again, one example how to do that with cloud-native technology. The point is how that works, in theory, and how we can now apply this using this cloud-native approach. Because now you don't have to build this yourself, right? You don't have to write some scripts that now, increase that and advance this rollout, but that is done for you. So that is one thing that we want to include. Now, what we can do actually, promotion completed, just for fun. Happy path is always, happy, but also boring. Let's include something that fails, right? So if I say coffee exclamation mark, or, let's change the coffee to a dot so we see a difference, or, well, how can I make this fail, right? So that was just a good rollout, but now I also want to test whether my rollout rolls back once, the response time is too long, or actually I have some errors, right? So let's write some fun code. If new random, don't do this at home. Next double is, I don't know, less than 30%. Then please throw an web application exception, right? Bam. Basically do something like we can have a response. That's now Jack's REST code. Status, or better, server error. Please find an error and say, so we see a difference, entity, niet coffee, right? Exclamation mark. And build this. Okay, so that is now my error. It will actually respond with a HTTP 500 and some default response in so and so many % of the cases every time we access our application. So then depending on what happens, depending by chance and random. Another pro tip: never do your live demos depending on chance or random. But let's see what's happening. And then what we can do, well, we can basically roll that out by, well, applying this, and again by pushing this, right? Now we made some change in our repository, and now, well, how we would do this, we see, oh, okay, yeah, looks good, ready for production, right? Okay, perfect. And commit changed response, or better yet, what we do what we always do, minor fix, minor change, something like this, right? Always name your commits properly. Especially a minor change that provides an exception for random, that's always a good idea. Nice. And then we see how our pipeline runs again. Now we will see the same stages that you saw before. So I can only do this twice because it takes a while, a few minutes to apply, and then it will be applied to staging, and then we can roll this out again. Have a look at that. Okay, so that's one thing, and then we see that deployment. So what you might have a look at in Jenkins X is the components that run here. So for example, it runs a lot of stuff already. So, oh God, let's make this smaller. These are all the pods that just run in my JX namespace, which is the namespace that is active here, JX, where all of my Jenkins X resources are, well, basically deployed. So you see, this already comes with a lot of stuff. It comes with some components, that basically listen for all of these webhooks that happen. Then we have something that is called pipeline runner that runs your Tecton pipelines. We have some garbage collection being built in. So all of these pods that actually run your task will at some point be garbage collected, and so on and so forth. Now, the interesting story is it's an opinionated approach how to build all of that together with Tecton and GitOps and all of that. But to be honest, and that's also the trade-off that you have to make, you really have to know Kubernetes and Istio in this case and Tecton pipelines in order to know what's going on. So it's supposed to be a very, opinionated, no-brain approach to just apply it and everything works out of the box. And it's kind of true, but in reality, you definitely, at least one engineer on the team has to know what's going on, what you're doing. So at least that's my observation yet. And because it's not fully there yet to just apply it and, a no-brain approach. I mean, the same if you operate Kubernetes, right? The same if you operate Istio. So at some point you have to know what's going on. You have to know what you're doing. So there's a little bit of a trade-off here, a little bit of some reality kicking in, right? I don't want to just sell you that technology. It's one approach that comes with a lot of stuff out of the box, but it's not fully, no-brainer. Kubernetes gets services that is there. So you see there's a few things that comes here out of the box. It actually runs a Nexus for your Java dependencies as well, a chart museum that comes in with your Helm chart, right? And the default pipelines that you can run, so I've run a pipeline that uses Jenkins with Maven with OpenLiberty, that's the application server that I'm running, that already connects all of these things, all of these tiny details that you otherwise have to provide, right? So if you build up a pipeline, I mean, you probably have done that by configuring some credentials so you actually can deploy to your Nexus here, and then you can deploy to your Helm chart, that you can build your Docker image using these credentials in your cluster, right? And all of the other things. And all of these tiny details have been set up here already in that opinionated approach. That's good. But at the same time, of course, you have to know what you're doing in order to use it then, in order to make it usable. Anyway, let's see how our pipeline is doing here. Once that is fully deployed, then we see that approach on that staging environment, and then we can have a look how that is doing in production later on. That all says coffee, that's good. At some point, now it is deploying. That is my staging environment. Now that new version will slowly be deployed on staging. Then we can test it. We can actually test that we get some errors on staging. But again, staging will just be deployed in our case without that canary approach, because we didn't activate Istio there. You could if you want, just for the purposes that in this case for staging it might be easier, or it might be an internally accessible environment if you want. And then we do the deployment again using that canary release, using that progressive delivery rollout in production. While we do that and while we wait for it, let's advance with our approach of what I want to show you as well, because I see that topic highly underrepresented in projects, which is testing. I know this is not a purely testing conference, but it's a very important topic. Why? Testing, especially testing in an automated way, only enables us to do continuous delivery, right? I mean, forget about progressive delivery, just continuous delivery. It's really dependent that we have some proper automated testing approach. And I run to the abstract also, that I want to show you how to do, some tests in a more maintainable approach. And that's actually a topic I find very, very, very important to make that maintainable, to keep, to make that being still relevant in your project. Right, so what you want to do in your pipeline is you want to be sure that every pipeline step, works well, and that you verify every step after you've done it, right? So that sometimes that's implicit. You build and compile your project, so you implicitly verify that you can compile it, right? Then in the next step, you would run some unit tests. That happens if you run your Maven pipeline. But then also the more important thing is how to do these end-to-end tests that you basically test against your staging environment or against your test environment, things like that, right? So what I show you here is from a different project That's a whole topic on its own, but basically just one approach to make your tests a little bit more, maintainable. What I have here is a system test project that basically tests some random coffee shop application from the outside that basically includes an HTTP client to connect to an application. So what I typically see in a project is that you create a test method with 200 lines of code to say, now do an HTTP client call, a GET request to this resource, check the JSON mapping, right, and check whether all of the information is correct. Now do a new, call, basically do a post against the system to, I have some coffee orders here to create a new coffee order, and things like that. What I think the most important thing is to keep your test maintainable and also to manage your test data is to care about code quality in your tests, right? To basically build proper delegation in and proper abstraction layers, right? What I have here, and that's basically one test that goes against the system and creates a new coffee order. I have some, coffee type with espresso from an exotic country, and I use, a delegate to create that coffee order, and then afterwards I go to that system and check whether the information is correct. Now the important part is, that one. I use a delegate that, in my test case, this is now Java code. I know some of you might not be familiar with that, but the point is not about Java code. To care about that test code quality, in this case, I basically have a delegate that delegates, how to get the coffee orders, how to create my coffee order and things like that into this delegate. By caring about these abstraction layers, that basically to say if something changes in your test, if your application advances, if you have a new feature, you only have to change, for example, this delegate, and you don't have to modify all of these test scenarios that you have, because your test code, your actual scenario is really short and readable, right? The same is true for managing test data. So if you say, okay, we have, a lot of, complex test data or a lot of complex scenarios that we need to manage within our test suite, whether that's the same project or some system test project or, written by whoever. Then this just helps a lot if you say, okay, you care about code quality, you put in proper abstraction layers and delegation in order to, create some shared classes that produce your test data, your test examples, in order to, apply that in order to maintain it a little bit better. A few other things that help is basically making sure that your tests are idempotent, that you can run, multiple tests at a time without requiring your system to be in a specific state. And ideally, what that means, you want to build up a pipeline where you just have some, let's say, system test stage that verify in an end-to-end approach whether your, let's say, staging environment works as expected. So that is crucial that you build this in order, to run your software properly. So I know there's a whole topic on its own, but basically the most important takeaway is that is, niet coffee. That was already a failure response, so you saw this is now deployed. But for the testing, that this is then verified in an automated way, so that something I did here does not happen, because then your pipeline would immediately fail, right? If, for example, you try to access that resource and you get a failure, then your system test would fail, which then is also part of the pipeline, so you stop that advance. All right. Now what I have here is basically the same thing that I had before, with a new version being in staging, and that version in production, that's still the old version. So now I quickly switch topics back. I now want to promote and deploy this version that I had here to now see, okay, what happens if my canary fails. So let's do this. Same approach that I did before. That was the promotion from before. And then after a while, I will see, okay, that I probably will get some failure here. Right. All right. So that is being said about testing. And with that progressive delivery approach, we can now wait until that is being fully rolled out. Again, point is, with testing, with progressive delivery, automation, right? You just want to define these approaches in a way that everything works in an automated way and that it works, without any human intervention, because that makes you able to sleep better at night, right? If you roll it out, whatever happens, either there's an automated rollback or fully rolled out if it worked, and all of that happens inside that cluster using this technology. All right, that is now being built and then being deployed on that production environment. You can have a look at this dashboard in the meanwhile. Now you see actually there's no canary being active. All of it is just on that main primary production path, which happens. You can have a look at these dashboards that are being typically provided out of the box. It's another advantage of this cloud native technology, right? So you just want to use something that is there already. And now we see that this went through. Then we can apply our Helm chart. Actually, we can have a look at these pull requests also. That's now my production environment here. That looks very similar. These are just pull requests that again deploy a new version, 29, which is now being rolled out. And now same story, since that Helm chart includes these Kubernetes resources like this canary release, then again this canary approach will be applied here. Once that is up and running. All right, I just want to make sure that this is being started so I can see, I can show you that this works as expected with basically the logs being provided in that approach. So that is the case here. And later on, what will fail, hopefully, is that metrics here. That metric of the success rate that then would be less than 99% in our case, given that all of these pieces pull together. New version detected, very nice. So, yes. That is now the case. We can have a look at the namespace of our production environment. Same story as before. Detected a new version, so it does not immediately roll out everything, right? But what it does, well, it has the primary version before, and that is now rolled out under the canary service, right? So, JX production, the other service, so that will be then applied by this canary service. Actually, inside the Kubernetes cluster, we could also directly go to this service or to that service if for some reason we just want to access the canary directly, right? Or of course you could enhance your cluster with some special gateway or some special route that always routes you to the canary, right? Or have that in an A/B testing approach, like I said before. So in this case, we always route the users based on some percentage, but you can also route it based on some HTTP header or something like that if you want. So in this case, that is a network, but what we will see once that is being rolled out, please give me my pods, yes, that then will already advance our traffic to 5%. We can check that with our virtual services. Okay, yes, now we already have 5% of a canary, and yes, niet coffee. That is already that failure, so that is already a failure response. I can actually make that a little bit faster. So we always try to access my application, and either, well, we get a successful response, or, well, that failure here, depending on, well, first 5%, so you see the dot by the exclamation mark. This is where you can see the difference in the successful responses. And at some point, once we have some, well, proper metrics being gathered here, so this is now, of course, built up for my demo, but typically what you would do, you would have these analysis phases way longer, right, than just 30 seconds or something like that, right? You roll it out for like multiple minutes or even longer, so then you can gather some proper information, and that it's statistically a little bit, more sophisticated rather than just having a bunch of requests. So then what we will see, now it complains that the success rate that actually I wanted to have 99% or more is now less than 99%, and then it says, okay, now please halt the advancement, don't roll it out further, just wait a second, and if it fails for so and so many times, then roll it back, right? So that is also a threshold that you will define, and then at some point, and what we will see that it will be less than 99%, or at least if the math random works in our favor. Well, maybe it doesn't. Let's see. That is now the interesting thing, whether we did that random high enough. And then in the other case, it will just roll it back and say, okay, roll it back in the other case, and then don't advance it further. So that's basically that idea. All right, we don't have to wait for that, because I have another interesting topic for you. Database migrations, yes. A friend of mine says functionality is easy, state is hard, right? It's one thing to say, oh, I have a Hello World coffee deployment that just says Hello World, and if I have something else, then I say goodbye world or coffee or no coffee. It's a little bit harder once data is involved, especially once data schemas is involved. So again, regardless of progressive delivery or not, that is always an issue once we do zero downtime deployments, right? Like blue-green deployments that actually Kubernetes does out of the box, right? If we have an approach where we say, without losing requests, switch from one thing to the other, then what that means, what it implies, that we have both versions, old version, new version, in production at the same time. Even if it's just for a few seconds or milliseconds, we have both of them active at the same time, and that means if our application typically accesses one database, like a standalone, old-fashioned relational database, then we have to be compatible with potential version schema changes at the same time, which is sometimes called n-1 compatibility. That means we are compatible with version n and with version n plus or minus 1 at the same time. Not plus or minus 5, only plus or minus 1, so two versions, the next version, it needs to be compatible. And in this case, what we do a rolling upgrade, right? We don't do some big bang change to our schema, again, right, where we say, oh, please drop this table, rename this column, right? Because then the application will fail. But what we do a rolling upgrade. That means we migrate in steps and not in jumps. How that looks like is roughly as follows. I have a different example for you here. Again, Java, because I like Java, that's a JPA example, but doesn't matter at all what you do on your application side. That is just one ORM mapping approach using JPA. What I do, I have a coffee order, of course, coffee again. And in this case, what I want to focus on is a coffee type. That is just an enum that says, espresso or something else, right? And assuming I want to rename that type, I don't like the column name, or type could interfere with some SQL or whatever, might be a reserved keyword. I want to rename this. Now, how do I do this? Assuming I have some SQL that created this table in the first place, so that says type, and now I want to call this, order type or coffee type or something like that. What I will do in this case is as follows, that I say, okay, I need to have migration scripts. Again, automation. So first of all, what I need to build up is an automated way, a process that can apply migrations while my application is running. And ideally, something that is compatible with the application version that I'm going to deploy. So that means an application version then is related to a compatible database schema version. So in this case, what I say, okay, version 2, not of the application, but of the database, for example, do something like this, alter table, and now I don't say rename, say add column, right? I add another temporary column, and also what I will do, I drop the constraint to, introduce that temporary column and change that existing column, the type column, in order to create a temporary one and the old one that are now not constrained to be not null, for example. And what I will do then, I have to have multiple code changes and multiple migration changes. This is what I mean with migrate in steps, that you need to deploy one after another in order to make that rollout. So for example, what I do here, I introduce a temporary field, which I don't have to use at all in my Java code, that introduce that new column. And then what I do, at first, I have these two fields that are not null constrained. Then I write to both and read only from the old one. Why? Because that old application version also only writes to that old one. It doesn't know about the old new one yet, right? I do this, and then in JPA I could say, okay, on an update, please set both to same value and things like that. Then in the next step, what I will do, now I want to write to both and read only from the new one. And in order to do that, first of all, I have to make sure that all of these values are copied, that both is the same before I apply the update for, and to make changes, to account for changes that have been made in the meantime. And then I can actually change that code to only read from the new one, which I conveniently do by just swapping these strings, and then it uses this one, the new one. And then I can already introduce some constraint, for example, set that to not null, because then all of the versions write to that column, all of the application versions. And then what I do here in this case, I just switch that statement to, then only use that new one here. I can remove the old one then from the code. And then the next and last version, I can introduce a new migration script, to remove that temporary /old column altogether, right? And by applying these things once after another, I can actually roll out by having everything active and everything being deployed the whole time. Now, what's more fun is rollbacks. Who of you defines rollback scripts? Hands up. Yeah, that's what I see in projects as well. That is actually a question that's a somewhat trade-off whether you define that rollback approach as well, because it comes with a few caveats, with a few gotchas. First of all, you have to define rollback scripts, which is not always straightforward. So, for example, from the first version to rollback to the original version, what you do? Well, you can drop that table again. Which might already be dangerous because what happened with the data that you added in the meantime and things like that. And not only do you have to apply these rules correctly, you also have to test them, right? If you write these rollback scripts, actually for each and every deployment you also have to test the rollback, right? Because who tells you whether the rollback script works, right? If the rollout script doesn't work, well, you see it because the deployment fails. If the rollback script doesn't fail, well, you have to test the rollback actually, otherwise you don't know. And things like that. So that's a whole topic on its own. The point is just you have to define such an automated approach. In this way, for example, what I would do, define the migration scripts, and then there's some technology out there for migrating these database statuses, or you define an own Kubernetes init containers that run before your actual deployment, make sure that the version changes, apply all of these scripts, and fail otherwise. You can test on your staging environment. Again, same story. You just need that automation. Actually, now it failed. Canary failed, and now we're back to our coffee. That's what I wanted to show you. So that is to be said about database migrations. It's just a topic that I always like to mention because it's an important one if we talk about zero downtime, right? And of course, progressive delivery as well, since we also apply all of these deployments, if they work, in a zero downtime approach, right? And with all of that, just the point is that you will be able to sleep better at night, right? Because everything that you do is applied in an automated approach. That's the whole takeaway here. So what progressive delivery does, you can test in production. It's a way to test your deployment in production, but by limiting that blast radius. So you don't affect 100% of the user. You might have different approaches, let's say the percentage base that I showed you. And the important thing is have an automated approach to rollback, right? Not just roll it out in a way that you say, I can have a look at it and I can switch back. No, that needs to be done automatically. You as a human must not be involved in that, right? And then for all of the migrations, try to migrate in steps, not in jumps. That is true for progressive delivery per se, right, with that rollout. That is true for database migrations, which need to be involved as well. And the point is, you put in automation for everything. And once you do that, you have what I call continuous improvement, right? Because you improve that whole pipeline and that whole approach each and every time you make some investment in it, right? Automated testing is one way, right? Once you define a test in an automated way, you improve the whole pipeline, right? Because the next time that test will be run as well, and again, and again. So you include that regression test. Same is true if you include that automation for your progressive delivery approach, right? You just improve that whole approach by putting that automation in. And the reason why I showed these technologies like Jenkins X for Kubernetes, what I really like about that open source cloud native technology, like Kubernetes, like Docker containers, like Jenkins X in this case, Istio, Flagger, what I showed you, is that just enables you, and it enables especially smaller companies, smaller projects, startups, to use that approach that has been out there for many, many years. What I show you is actually nothing new from the concept, right? But it's now more approachable, it's actually usable without having a huge time investment and a huge team of engineers, of operation folks to apply that, right? It's still a lot of effort, to be honest, to understand it, to manage it well, but it comes with a lot of things being provided, and you don't have to write your own shell scripts for each and everything. You can start up with a very sophisticated and opinionated approach already. And I think that's a very nice idea in general, and maybe you are now inspired to have a look at these technologies as well. And in any way, I hope this was helpful. And spasibo большое. Thank you very much for your attention.